I want to talk about my personal answer to a common question, which is what is a programming language? So you might have heard people arguing about programming languages being good or bad, usable, unusable, and stuff. But then what are people actually talking about when they say what a programming language is? Right, so I'm going to give my own personal interpretation in the next 15 minutes. So at its core, a programming language is actually a document. So this is the, you can download this. This is enthralling reading. This is the specification for JavaScript, which is also known as ECMAScript for boring historical reasons. It's 566 pages, so I'm going to spend the next 15 minutes going through this. All right, it's in French also and other languages. And so the C++ one is about 2,000 pages, so be glad you're not seeing that talk. So if you actually scroll through it, it basically is a bunch of English that describes the syntax and semantics of a language. Right? So when someone asks you, what is a programming language? You just say, this is a programming language. In theory, this completely describes the language, all the details of what the code looks like, what a particular piece of code is supposed to do, and all the kind of hairy, gritty details with varying levels of formalism. So every language has some kind of a specification document like this, either written by one person or more commonly by these committees that say what the language is. And this is from 2015. So JavaScript is actually constantly being updated. So every year or so, there's a new version of this spec being put out. So this should be everything. That should be it. So if I give you a program written in JavaScript, you should be able to tell me exactly what it does in theory. Right? You should just be able to go in this document and look up the right pieces of syntax and look up the right semantics and actually manually run your program. Right? So that's great, except for it being kind of slow. So in reality, since we have computers, in order for any programming language to be practical, we should implement it on a computer somehow, so we don't have humans running it. So that brings me to the second layer, which is implementation. So this is one popular JavaScript implementation currently. So JavaScript implementations are sometimes called JavaScript engines. So V8 is one that is an open source project that was originally created by Google. And it is called a just-in-time compiler for JavaScript. So what V8 does is that it implements this spec so that when you give it a JavaScript program, a piece of code, a piece of text represented in JavaScript, you can run it through V8 and it will do something and print out the results or like modify your file system or do something. So it is an implementation of this spec. So V8 isn't the only one. There are other similar JavaScript implementations made by other companies and other open source projects. It just happens as a pretty popular one. And one main feature of these implementations is speed and efficiency, right? So all else being equal, you want your implementation to run code faster or with, taking up less memory than other people's implementations. So in the JavaScript world right now, there are a few leading implementations that are actively competing for speed and for memory efficiency. And increasingly, as things go on mobile, for energy efficiency as well, right? You want your code to be small and run fast and not take a lot of energy. So that's great. So we have a specification and we have an implementation using JavaScript as an example. But what does it do? So if I gave you V8, if you actually got the binary for V8 and you gave me a bunch of JavaScript code, that's probably good for running the kind of programs you would maybe write in a class that you're learning, right? A command line program that runs a loop, creates some objects, prints out some output. But in the real world, those kinds of programs are fairly limited, right? Except if you just want to do kind of toy examples that you're learning in class. So, what people often mean by a programming language or how it's applicable is beyond just an implementation, beyond a particular compiler or a particular interpreter. What they really mean is the language needs to be situated in some kind of runtime environment. So that's the third layer, is the runtime environment. So for JavaScript, the reason I picked this example is that everybody is familiar with runtime environments for JavaScript because the web browser I'm using right now, Google Chrome, is a popular runtime environment. So Google Chrome has the V8 JavaScript compiler inside of it, along with a rendering engine for HTML and for other things. So when you're visiting these web pages, all the dynamic stuff that's happening in the web page, all those annoying ads that are popping up, all the monkeys or whatever that's going across your screen is running JavaScript code in this V8 engine. But it's not just running in isolation, it gets to interface with the rest of your web browser. And that's what gives rise to all these modern web experiences that everyone is used to. So, for historical reasons, JavaScript is now one of the most popular programming languages Not necessarily because these syntax and semantics are amazingly beautiful, but because everyone is using web browsers now. So it just happens to be the only language that natively runs in a web browser. So JavaScript doesn't only run in a browser. So recent years, in the last 5 years, a project called Node.js has made JavaScript popular as a server-side programming language as well. So if you are making a web application on the back end, on the server, you can now use JavaScript. And what Node is it actually is it's the V8 JavaScript compiler coupled with a bunch of libraries and other kinds of features that are useful for writing web servers and server applications. So this is now extremely popular for not only writing in-browser code, but also server code. And the nice thing about having one language on your browser and server is that you can reuse code, right? If you're writing a bunch of code that's for your particular business logic or a particular kind of company needs, you can actually reuse them on both the browser and the server. So you don't have to write your server in another language. Also, another really exciting development in the JavaScript world in the last, I would say, 2 or 3 years or so, are people actually now are starting to use JavaScript to write desktop applications of the sort like Microsoft Word or Excel or iTunes and stuff. So you normally think of web applications being written in JavaScript as only running in a browser. Right? You start a browser, and then inside you have Gmail or Google Maps, but it's all in your browser. But you think of these programs, Safari, Skype, iTunes, Word, Excel, PowerPoint, you think of these as being written not really in JavaScript. Right? You think of them being written in C# or C++ or Java, or these kind of desktop programming languages. And in fact, there's absolutely no reason why you can't write them in JavaScript as long as people provide a runtime environment for it. So this project called Electron, it used to be called Atom Shell. It's an open source project made by GitHub. This is a really exciting project because this allows you to build desktop applications that are cross-platform using JavaScript and HTML and stuff. So a bunch of software, I think the Slack desktop client is made using Electron. A bunch of software, these are ordinary desktop applications, are made using this Electron framework. And what this basically is, the trick with this tools is that it basically is the V8 the V8 engine, and it actually all it really does is it gives you a browser window, except it takes off all the browser-like things, and it gives you functionalities like icons and access to your file system and stuff. So you should check this out if you haven't already, because you can now not only make websites in JavaScript, not only make web server software in JavaScript, you can make ordinary desktop applications of the sort that Word and Excel and stuff. And all of this is powered by the fact that JavaScript engines now are getting pretty fast, right? They're getting competitive with something like Java. Okay, so that's great. So we have a spec, we have implementation, we have some runtime environments, so we can actually do something useful with our code. What's next, right? So if we just have that, then we can write a bunch of code using using just kind of the built-in operations the language gives us. Like you can add a bunch of numbers really fast, or you can subtract numbers, or you can take you can divide them and such, or you can create a list of strings. But that's not that useful beyond just really basic functionality as well, right? So the next layer in a programming language is the standard library. So every language usually comes shipped with some library of functions and classes and objects for doing useful things. So here's one of the implementation of JavaScript standard library. This is one from Mozilla, and it has objects like kind of numbers, number operations, dates, text string processing, collections, and such. And a lot of times the standard library is actually specified in the spec of what the standard library should be. Unfortunately, JavaScript is not super well known for having a great standard library. It's very minimalistic, and it's inconsistent across different implementations. I think a better example for a standard library, just my personal one, is Python. Other languages like Ruby and Java also have really robust standard libraries. So Python standard library is really nice in that it has a lot of well-made functions and classes for doing basically everything that you need to do with basic programs. There's a lot of them that goes in there. And that's what, when people talk about languages like Python or Java, Ruby as kind of batteries included, it means that you install that language on your computer. You're not only getting the language compiler itself, you're getting a bunch of functions right out of the box that you can just use right away to write your code. And that's an advantage not only for the programmer, but for someone running your code, right? So if someone grabs a piece of code, they don't have to install any other libraries or any other things on the computer, and they can still run it. So it's really useful for having your code be portable. So now you can kind of see where this is leading. So we have a standard library now, but what about if you need other code that's not in the standard library, right? So then we have these third-party or external libraries that, that people make. So the great thing about open source is that anybody can make a library, put it online, you can put it on your website, and if people like it, they can download it and use it in their code with some license and terms. And that's what's really allowed open source to really flourish. So a language really flourishes a lot of times based not only on the quality of its implementation and runtime environment standard library, but on the ecosystem of third-party libraries and external libraries that the community has written. And for that, JavaScript's actually done a really good job. So NPM is a package manager for JavaScript. These exist for other languages as well. And you basically can find packages. So this is a package for working with Twitter. I'm sure you can find a package for working with Facebook data. So basically, you can search and find packages of libraries that people have made to work with various sorts of data and APIs. So it gives you example code, it gives you installation instructions and stuff. And NPM is now one of the biggest repositories for any language. So if you actually look at this website, this module counts website, these are the package management systems for common languages. So you notice how, where's NPM? This is the one for JavaScript. Whoa. So the one for JavaScript, NPM, is just growing like leaps and bounds, and it's growing at a faster rate than everything else. But other languages like Java, .NET platform, Ruby, this is for Python, they all have kind of a reasonably growing ecosystem. So one of the, when people are arguing about languages and saying, oh, this language is better or worse, or why isn't this language used more or less, a lot of it is due to this ecosystem around it, right? That, the syntax and semantics may be one thing, but if you have, pick your favorite language here, and if the packages simply aren't available, you're just not going to get this large developer base and this critical mass. And a lot of times this stuff just kind of exponentially increases and builds on top of each other. So thinking a lot about fostering a good third-party open source ecosystem is really important for language success. And again, notice how this has nothing to do with the document, with the specification, right? Your language could have the weirdest, syntax and semantics ever, but still be extremely successful in the market. So a great example of this from the prior decade was Perl. So Perl was kind of the really, and now it's still pretty, fairly high up. But so CPAN is this package manager for Perl that really kept it going throughout about 15 or 20 years of history before kind of the modern web stuff took off. And it wasn't because people loved all the weird things about Perl, it was because anytime you want to do something useful, you could search on the CPAN repository, and there was useful code to do that. And then just more and more people wrote Perl because of that. Okay, so the final layer of a programming language, I feel, kind of the broadest interpretation of the programming language is the actual community of people around it. So community can be kind of construed as in-person sorts of conferences. So JSConf is a series of international developer conferences for JavaScript. You can imagine that people go there to share their latest kinds of tools, share technologies, to kind of share new libraries that they built. So having a thriving community of people is actually super important, because in the end, it's the people who are actually implementing these languages and libraries and using them and getting them to spread. So whenever you're trying to build a new language from scratch, so Google did this with the Go language a few years ago. A big thing that they had to focus on was actually building up a healthy developer community, both in person through conferences and also online, right? Good help forums, good mailing lists, just good kind of etiquette about how do you bring more people into the fold of your language. Because in the end, you could have the most amazing language in the world, but if no one's using it, it's not going to succeed. So an anti-example for this is Linus Torvalds. So the Linux kernel community is widely known for very harsh sorts of words around. I should probably not show these slides too much, but if you're developing for open source projects like Linux, they are very well known for being extremely harsh towards newcomers and beginners, and even people who've done it for a while. And so this is kind of an anti-example of how if you want to build a large and thriving community, you probably shouldn't do this. So in the end, this talk is up on my website, so you can go just search for what is programming languages, and there's a big burrito picture here for some reason. But so these are the 6 layers, because it's like a burrito, right? And I kind of go through all of them. So specification, implementation, runtime environment, standard library, third-party libraries, and community. So I feel like this, what you learn in school is really this, right? So when people are talking about teaching programming languages in school, myself included, you're really focusing on the kind of mathematical parts and the kind of systems building implementation parts. But I think for languages that thrive in the real world, there's just so much beyond this in this burrito analogy. There's so many layers above it that aren't really covered in an academic setting.